Hello, this is video number 5 of the vertical projectile motion. We are interpreting the graphs. I have two graphs here, that is the velocity time graph and the position time graph. So we are going to just analyze how to answer questions, how to calculate, and so on and so on. How to calculate the position, how to calculate the velocity, how to calculate the time, and so on. Okay, let's start with this graph. Where is it? Let's start with the velocity time graph, this one. Okay, these are definitions, projectile, and a free fall. Now let's analyze the graph. This is the velocity time graph, and we said the velocity time graph is linear. Okay, velocity time graph is linear. You'll remember that from grade 10 we have these formulas. Formula number 1, that was a formula for calculating the velocity, which was equal to delta x over delta t, okay, to calculate the average velocity. Then we have another one of calculating acceleration. It was change in v over change in what? In time. So we are going to interact with these formulas, right? Okay. Another one is, it's only these two, so we have this one and this two. Okay, now what is important here is to make sure that since we have velocity here, then in this side we have what? Time, which means the graph is velocity time graph. Therefore, you rearrange your formulas so that the velocity and time be in one side. It's either they are multiplying each other or they are dividing each other, right? Now if you can look here, we have velocity and time in opposite sides. So kweli cala we have the velocity, kweli cala we have time, which means you can cross multiply so that we will have them in one side, which means we have delta x, which is equal to v delta what? Delta t. Okay, but in this one is correct because v and t are in one place. V is divided by t here, v is multiplied by delta t. So this is the formula that we are going to use, and this one is the formula that we are going to use in this graph. Okay, now the first thing that you need to know is that we have some areas here. Let me just take this one. You see this area between the x-axis and the graph? This is the triangle. This is the triangle. You look at this one, this is another what? Triangle. This one is another triangle between the graph and x-axis, right? And here you can make a triangle and a rectangle. This is a what? A triangle and a what? And a rectangle. So we have the areas here. So if you multiply length times breadth, that is the area. But if you divide, let's say length divided by breadth, that is a what? A gradient, which means we have two formulas that we can use. That is area. If it's a triangle, it's 1 over 2 base times height. Then if it's still area, it can be length times breadth. It will depend on the figure you are talking about. Then another one is a gradient. The gradient is represented by m is change in y over change in what? In x. So in this case we have v as y. This is our y. Then we have t as what? As our x. Yeah, which means this is v over what? Over t. This is v over t. Now v over t in this case is acceleration, which means the gradient of this graph represents acceleration. Gradient of velocity time graph is acceleration. Is 9.8 meters per square second, always downwards. We write that. Okay, so that is the first thing that we need on this graph, is that when they ask which physical quantity does the gradient represent, you must know that the gradient of this graph is acceleration. That is gravitational acceleration is the gradient. Gravitational acceleration is the gradient here. Then another thing that I talked about is area. Area, you multiply two things. So if we multiply the area, remember the base is the what? Is the time. The height is the velocity. So we have v times time. So this is our base or height, this is our height or base. So this is our base, that is time, this is our height, that is velocity. Oh, we get delta x there. Okay, so when we multiply delta x, in this case is equal to v times delta t. This is the area. This is the area. It will depend. If it's a area of a triangle, just put half. So the area of this graph represents what? Displacement. Displacement. Right? So this is how it is. So you must know this. Another thing that you need to know is to analyze the graph using equation of motion. Okay, so you must know the initial velocity, you must know the time, you must know the final velocity. You must be able to calculate using the equation of motion. That is the simplest one. Okay, so if we are using the equation of motion, the starting point of a line is your initial part. So we have 10 here. This 10 is our initial velocity. So that is this one is your final velocity. Now, if we want to calculate the displacement here, you can just use, this is your initial velocity, this is your final velocity. You collect the data, you just say this is initial velocity, that is 10. Okay, and it's positive, no need for direction. Okay, then we have this one is a final velocity. This one is a final velocity, that is your final velocity, which is 29,6, right? Then you are looking for dy. You are looking for dy. Now, if you can look here, the line is going up, is increasing. The line is increasing. The line represents what? The gradient. The acceleration, I mean. So our acceleration in this case is positive because the line is positive. Very simple like that. So it's positive 9,8, not negative. Then you choose the correct formula. Based on this one, you are going to use final velocity square, which is equal to initial velocity square plus 2a delta y. Then you calculate delta y. Then we're done, right? Then looking at this one, this is your initial path part of this line. This is your final part. If they say calculate x. X is on the y-axis, that is velocity, which means we are looking for velocity. In this line, this is the initial velocity, this is the final velocity. Or you can say this one is the initial velocity, this one is a final velocity, no problem. But if we take this one as initial, this one as final, therefore the time will be this time. So delta t there, so our delta t in this one will be this one, that is 7,71 minus the starting point, which is 2,2. Then you get your time. So this is your initial velocity. Your initial velocity in this case is x. Your final velocity in this case is 27. Okay, so the acceleration, the line is still increasing, therefore the acceleration is positive 9,8. Then you calculate for the value of x. Then let's look at this one. This is your initial velocity, this is your final velocity. The velocity here is 0, so the velocity is 0. So we have the initial velocity, which is minus, initial velocity is minus 25. Final velocity is 0 here. Final velocity is 0. Okay, final velocity is 0. Therefore delta t will be equal to this t, that is t, minus the starting point of this line, minus 8. Then you get your delta t, then you solve for t. The acceleration, the line is still increasing, so the acceleration is positive. Acceleration is positive 9,8. Then we're done with this one. Let's go to displacement time graph, that is position time graph. Here is the position, this is the position. Position, remember, is represented by delta y. Then we have this one, delta x. So if we can look at that formula, velocity is delta y or delta x. So here I said delta x, so you can just say you can put y here, since we are talking vertical, about vertical projectile motion. Delta y over delta t. Then another one that have, there is no one that have what, delta y, except this one from grade 10. So it simply means that okay, in fact we said since dy not dt, mabe uqalele 1, sebekuqalele 1 already, therefore the formula is correct. This is the formula. All right, so the only thing that you can calculate here is the gradient. So this one is the gradient, because when you divide something, you are calculating the gradient in this case. So the gradient of the graph represent, so the gradient, average gradient, represents the what, the velocity, the average velocity. Okay, so we are going to calculate the gradient. It represents the average velocity only, nothing else. Okay, we are not going to calculate the area here, because if we multiply this and this, there is no physical quantity we get by multiplying dy and delta t. Okay, so this is very simple. This is the position, this is the position, first position. It was dropped or thrown from 2 down, then it bounced. That is the first bounce, this is the second bounce. So we have 2 bounces here. Then this is the height, maximum height for the first bounce. This is the maximum height for the second bounce. Now if we want the velocity, we have the velocity or the initial velocity. For example, we have delta y here. This is our delta y. Looking at this line, this is our delta y, right, which is equal to 2. This is the starting point. Then this 2 is below the starting point, down, because it's decreasing to 0, so it's decreasing to 0. Then we have the time, that is, this is delta what? Delta t, which is 0,64. That is the time here. Then the acceleration is 9,8, always downwards. Now we're looking for the velocity, that is initial velocity. Then you use this formula, right? Or you can just calculate the average gradient here, but it's not easy in this case, so it is wise to just use the equation of motion. Then you get the velocity of this line, right? Then we are done with that. Now let's analyze here. We have this height, right? Or in fact we have this height, which is delta y. Then we will want t this time. Maybe on the statement we will be given something from here, so it is very easy. So and the velocity here is equal to 0 because this is the maximum point. The velocity here is equal to 0 because this is the maximum point, the turning point. So we have this initial velocity, then we have this time. Maybe we'll be given the final velocity here, or we'll be given the initial velocity here. Then it will depend on the questions. Okay, that is how we analyze the graphs. Thank you. Make sure you subscribe. Thank you.